You guys familiar with the Windflow turbines? So one of my favorite, I got a lot of favorites in here, so I'll just highlight my favorite ones. This was a really fun one because of a failure. And again, I'll always go back to failures. Failures are kind of an interesting thing. They're like anything in life. When we get something doesn't work right, it's an opportunity to learn. It's an absolute opportunity. It's like a golden opportunity. So when your partner or your friends or your whatever is getting on your nerves, that's an opportunity. May not feel like it, but the reality is that there's a reason why you're letting that get you going, and you can do so, you can learn from that if you want to. And failures are that way, and so my clients come to me all stressed out, and for me it's like, whoo-hoo, I get a chance, we can figure something out. So Windflow is a classic opportunity. So Geoff Henderson's the owner of Windflow, and he was a really great engineer. He was one that kind of reviewed me for my registered engineer status when I first come to New Zealand, and I really respect the guy. But they had a gearbox that they had designed for a wind turbine, and that wind turbine got backwinded at one point, and it ripped the gearbox off the tower. You guys remember that?
Gebbies Pass.
Gebbies Pass.
Half a mil to a mil, something like that.
And so that was a huge opportunity to learn. So Geoff was really smart in that he said, I don't know what caused this. Let's look at a lot of things. And he gave a lot of people opportunity to really look into some things fundamentally. And so we were looking, Motovated was looking at, look, we know it got backwinded. What happened in that context of the backwinding? And we were looking at all kinds of things. We're looking at resonant frequencies. Was a resonant frequency enabled? We were looking at, did the dampers and the soft and hard stops because the really cool thing about the Windflow turbine, do you guys know about it?
It's a teetering turbine, two-bladed, which is unique in the world.
Yeah, teetering. So it basically allows itself to kind of wobble back and forth. So your wind profile is not linear. There's almost no wind at ground level, and it increases as you go higher. And so there's by definition a variation in the wind speed that the turbine sees as it goes through its stroke. You also have a lot of other complex things that I probably am not competent to comment on, but there's a good reason why each of those blades can teeter, so they can wobble this way, but the teeters can pitch themselves in the context of whatever it's seeing to get itself back to square. And that's such a brilliant idea. That was one that Geoff had when he was at a wind turbine farm in California. Came up with this idea of this teetering wind. And so he developed Windflow to enable that technology. And another thing he enabled was a gearbox that got rid of excess energy. So one of the challenges you have with a wind turbine is you get gusts that are way too strong for it. So you build this huge structure, you build this huge tower, you build this huge gearbox, build all these things to handle these big wind gusts, but they don't actually help you because you can't absorb them. You can't create more energy out of your generator with them. So they're wasted energy. And so what Geoff did was he just wasted that energy. He just said, okay, well, let's have something else that the gearbox does that dissipates that energy so it doesn't go into the tower, so it doesn't go into the this and that. And so he had two technologies in that were world new, world first. Really fundamentally great technologies. Oh, and the other thing was that he made the turbine synchronized to the resonant the frequency that the electrical power was set out. So in New Zealand it's 50 hertz, in the US it's 60 hertz. So his turbines spin at those speeds so that they develop that resonant frequency automatically, or the resonance of the gearbox generator. They can use a cheaper generator is what I'm saying, because it's already tied to the grid at the right frequency. I'm explaining all that bad because that's not my specialty. My specialty is the structural analysis, and what we did on that failure of that. So this picture here isn't the failure thing, but I did a bunch of highly nonlinear dynamic analyses that highlighted how the bolts broke in the context of the gearbox getting ripped off the thing, and in that we were able to design a bolted structure that would absorb that energy the next time if it ever got backwinded again, so it wouldn't rip the gearbox off the thing. So for me, that was a heap of fun. And we all learned a lot from it. And one of the things that came out of it was something simple that I used a lot over my years, and well before I ever knew that, is long bolts. Is anybody aware of long bolts? What the value is? Go for it.
I first came across that on the Britain engine, they used long stretching bolts.
So what's the value of it?
They're like a spring, really, aren't they? I've never really seen, because the range is so short, you tend to intuitively not see them as a spring, but they store energy, they are essentially springs.
Exactly. And a bolted joint is a really interesting joint to the engineer. And once you get into the math of that, you really see why it works the way Clinton's saying. But a long bolt, and the thinner it is, the springier it is, obviously, that's a dynamic absorber of energy. And so what we did to fix this was we put longer bolts and shimmed them up really high. And so all we did was absorb more energy in the context of the bolt. And it's not just the bolt, it's a bolted joint. So in preloading a bolt, you put the area around it in severe compression, just like you're putting the bolt in severe tension. And that is, both of those are springs. And both of those are absorbing the energy as it stretches and contracts. It's a really cool thing to get your head into. It takes a bit. Like I'm not able to explain it to you well enough right now. But if you ever analyze a bolted joint, it'll basically blow your mind about how powerful that is. And so all we did to make that better was make the bolts longer.